Hello everyone, I am Dr. Nitin Kumar Saxena, and in this lecture I am going to discuss about the electrical charge. So what is basically electric charge? When we talk about electric charge, we start with any molecule. Any material has so many molecules, and if we go for the structure of molecule, then every molecule has number of atoms. So when we talk about the atoms, so every atom has nucleus, and around this nucleus electrons moves in the shells, and these nucleus has two elements, protons and neutrons. And I said earlier that the electrons moves around this nucleus in the atom. And normally we say that this proton is a positive charged particle, while this neutron has no charge. This means this is a neutral particle, and electrons which moves around this nucleus is negatively charged particle, right? The value of the charged particles normally as given by this value is 1.6 into 10 to the power minus 19 Coulomb. Coulomb is the unit for this charge. Normally we denote in short by C. And for same for the electrons, the value of charged particle is 1.69 10 to the power minus 19 Coulomb. And in any atom, the number of protons are always equal to the number of electrons. So the protons means positive particles which are in the nucleus, and the same number of electrons moves around this nucleus, and therefore the overall polarity, or we can say overall charge on atom, is 0, because the number of protons is equals to the number of electrons in any atom. So therefore it makes the atom always neutral. But what happens like, depending on the nature of the different atoms, the materials, we can say that the possibility for some atoms are such that they can easily donate the electron, and some atoms are such they can easily receive the electron. If, for example, I'm giving you an example of sodium. The sodium has the atomic number of sodium is 11, and from the basic knowledge of the chemistry we can say that atomic number 11 means the sodium has 11 protons and 11 electrons which moves around the nucleus, and they moves in three shells. First shell has 2 electrons, second 8, and third has 1. Similarly, if we talk about the chlorine, so chlorine has atomic number 17, and therefore it has 3 shells. In first shell 2 electrons, second shell 8 electrons, and in last shell at 7 electrons. So you see, for being stabilized, every atom want to be stabilized, and for that purpose it can easily receive 1 electron, and it can easily donate 1 electron. If it donate the electron, then after donating the electron it would be positively charged because it has given 1 electron. So now after giving the 1 electron, number of protons are 11, while number of electrons are 10. So 1 proton is more on sodium. This means it would be positive in nature, or we can say in other words that if an atom is releasing electron, it becomes positively charged. In the same way, if I am giving 1 electron to this chlorine atom, what will happen? Now the number of proton is 17, number of electrons are 18. So 1 more electron, and since electron is negatively charged, so the charge on chlorine will be negative. In other words, we can say if any atom is receiving the electron, then it becomes negative. Or we can say since electron is negatively charged, if it is going out from the atom, it is going away from the atom will become positively charged. If it is coming to the atom, then the atom will become negatively charged. And in this way, we can say that overall, if you see this structure, normally what happens? Na becomes plus sign and Cl becomes minus sign. If you know the basic structure, what is NaCl? This is the chemical name of your salt. And you see here that when we are seeing this chemical structure of salt, so normally sodium Na has shortage of 1 electron, while chlorine has additional 1 electron, and they form a bonding between Na and Cl, and combined name is NaCl. And in this way you see that electrons are shifting only from one atom to another atom, and therefore we can analyze, or we can conclude that the number of charged particles always remains conserved. It cannot be destroyed and it cannot be created. It will be shifted from one atoms to another atom and so on. Right? But doesn't mean that single electrons or single proton does not exist. It also exists. But the same thing, if there is one electron existing, then their supporting proton that will neutralize this electron plus proton structure will be available somewhere in this space. Maybe at some place, maybe at different place, maybe at infinite. That's a different, that technical term, that's a mathematical term. But if there is an electron, then there must be its supporting proton somewhere in this space. And this is called the conservation of charge, right? Now you see, the next point is, since we are saying here that the next point is, you see that the next point, that proton is positively charged and electron is negatively charged, and we have like positively charged, in this way we can say positively charged and negatively charged atom or any molecule atom. So we will see that if we have the same charge like plus q and plus q, they will repel each other. Similarly, if we have same charge minus q, q I am denoting the symbol for charge. Q denotes the symbol of charge. So here I am saying that any atom, any substance has plus q charge, and the same another one has plus q charge, and they are placed with each other, then what will happen? They will repel each other. Similarly, if the 2 minus q charges are at some place, then they will again repel to each other. While if we have 1 plus q charge, 1 minus q charge, then they will attract each other. They will attract each other. In this way, we can conclude that opposite charges attract to each other and same charges repel to each other. Now, suppose I want to make a body I want to make a body to be charged. I want to make a body to be charged. Then, how can I apply the conservation law for the charge? As I said, the charge cannot be destroyed nor created. But my question is that how can I make a charge on a body? For example, if I am saying that there is one sphere, right? So I want, this is something like this. So this is at a stand, and this stand is totally a material for which it is not possible the charge can flow. The flow of charge cannot be possible for this stand. Okay, now what is the question? The question is, I want to make this sphere positively charged or negatively charged. So let me allow to take that I want to make this sphere positively charged. If I want to make it positively charged, what I will do, I'll bring a rod near to this sphere and say this rod is negatively charged. This rod is negatively charged. Since this rod is negatively charged, so what will happen? Due to this negatively charged, since this is the material, and you know that every material is made up of the atoms, and I said that atoms has both protons and neutrons, so means positively charged particles as well as negatively charged particle. So what will happen? If you see here, then you will find that if I am bringing a rod which is negatively charged to this sphere, now the sphere positively charged particles and negatively charged particles, which are normally are randomly distributed anywhere, maybe anywhere in the whole sphere. But now since this negatively charged rod is coming here, so what will happen? All the positively charged particles of this sphere will be attracted towards this rod, and negatively charged particles will be repelled away from this rod. Okay. Now in next step, what we will do? We will from this side, from the other half side of this sphere, we will connect some earthing. Earthing means we are using a conducting wire which is allowing to flow of these negatively charged particles from this conducting wire to the ground. This symbol is normally used for making the connection with ground. Other, it is also called earthing. Okay, it is also called earthing. So what we are doing? We are simply allowing to flow these negative charged particles towards the ground. Now what will happen? When you are allowing this negatively charged particles to go in earth, now you have only this structure. Now this sphere is positively charged. Why this is positively charged? Because all the negative charged particles we have allowed to go in ground through conducting wire, and now we have replaced the conducting this grounding also. Now this whole sphere has only the positive charged particles. Now again, next step, what I am doing, I am again removing this rod away from this sphere. As soon as I will allow to go this rod away from this sphere, now these positive charge particles which were attracted toward this half side of the sphere will be free to move in the whole sphere. And what will happen? The whole charged particles will flow, will distribute in the whole sphere, and hence in this way we can see now our sphere is positively charged. So this is the way how can we make any material, any metal conductor, that we will see later what is conductor. So any metal sphere positively charged without touching it, the same process we can adopt if we want to make this metal sphere negatively charged. In that case, we will bring a rod with a positively charged rod. Is it fine? I hope. Now next move to the next point, and next point is, since we have studied what is the positive charge, what is the negative charge, what is the value of what is the charge value on one electron, what is the charge value on one proton. So let's see the new topic. The new topic is that what are the properties of charge. Next is properties of the charge. So the first property of the charge is number 1, additivity of the charge. Additivity of the charge. Charges can easily be added. As I said, that if you have 5 electrons and you are giving more 4 electrons, then the total electrons will be 9. And these charges can be added algebraically. What does it mean by algebraically? Algebraically means if we have 5 proton, or in this way we can say that if a metal has plus 5 Coulomb charge, and now we are giving extra minus 4 Coulomb charge, so the value of net charge on this material is plus 1. So since we are using the sign also, that this 4 Coulomb means we have negatively charged, this 5 Coulomb is positively charged. So we are using the charged particles with their sign, and when we are adding algebraically, when we are adding with sign, this is called algebraic sum. So our charges can be added by using the algebraic method. Is it fine? The second is charges are always conserved. As I told you earlier, number 2, charge is conserved. The charge always remains conserved. If we see the last example of the metal sphere, so what we see that initially the metal has number of positively charged equal to the number of negative charge, but now finally we send the negative charge to the ground. Now this metal sphere is totally positively charged, but it doesn't mean that the negative charge does not exist. It exists. Where it does exist? It exists in ground. So in this way we will say that overall charge will remain conserved. If we have the positive charge, then its corresponding negative charge will exist somewhere. That somewhere may be ground, maybe other material, maybe other metal, maybe other atom, or maybe at infinity. But it will remain, right? And this is called conservation of charge. Third is quantization of the charge. Third is quantization of the charge. Quantization of the charge. As I told you, that the smallest unit, smallest thing which is related with charge is the charge on electron or charge on proton. And the charge on one electron is 1.6 into 10 to the power minus 19 Coulomb. Similarly, on proton is 1.6 into 10 to the power minus 19 Coulomb. So any material, any metal, any atom can have the integer number of charge, maybe 5 electrons, 10 electrons, 20 protons, and so on. So they will be in the value of the integer times. Okay, so this is called quantization. We can quantize, we can give you the number, and this is called quantization of charge. So these are the properties of the charge, that charge number one may be additive, may be conserved, remain conserved, and always it's quantized. Okay. Now if you, I'm giving you the brief, what is the conductor and insulator. You all know from the basic classes that if charges are free to move through the body is called conductor, and if the body does not allow the flow of the charge, it is called insulator. So I hope it's a very basic thing, so you know well. So I'm not going in much detail about the conductor and insulator. The fundamental knowledge of the conductor and insulator is, if a body allows the flow of charge, it is called conductor. If the body does not allow the flow of charge, it is called insulator. Now after this we see that if we have some particles, positive particles, negative particles, charged particles, and I said you earlier that opposite charge attracts and same charge repels. This attraction and repulsion causes a force between the charged particles, and this force is given by the scientist Coulomb's, and the law which is used to know this force is called Coulomb's law, right? So if we define what is Coulomb's law, so Coulomb's law can be defined that if we have two charged particles which are placed with each other at some space, then depending on the nature of the charge, they will experience either attraction force or repulsion force. They may experience repulsion force or they may experience attraction force, and this force is given by a certain formula, and this formula is given by Coulomb's law, given by the scientist Coulomb's, and this law is called Coulomb's law. So what is the formula? Let's see the formula first. So according to Coulomb's law, according to the Coulomb's law, that if we have two charged particles Q1 and Q2 placed at some distance r, then they experience a force. The force nature will depend on the nature of this charge, and the value of this force is directly proportional to the product of the charged particles and inversely proportional to the distance between the charged particles. If we use a constant for this Coulomb's law, this 4 pi epsilon naught Q1, so this 4 pi epsilon naught, 1 upon 4 pi epsilon naught is a constant which is used to define the relation from this Coulomb law. And if you see that pi is the standard thing, you know the value of pi, 3.14, or you can say 22 upon 7. This epsilon naught is called permittivity of the surrounding. You see that these Q1 and Q2 are placed somewhere. So what are the property of this somewhere? It may be space, maybe vacuum, maybe any material. So the property of this surrounding is called the permittivity. And normally when we are we are starting this formula, then we are assuming that Q1 and Q2 are placed in vacuum, and in vacuum we say the permittivity is of vacuum, and the value this is permittivity of vacuum. Okay, and the whole value of this 1 upon 4 pi epsilon naught is given by 9 into 10 to the power 9. The value of this 1 upon 4 pi epsilon naught is given equals to 9 into 10 to the power 9. How it comes? If you want to know that how does it come, then simply you know the value of pi, you know the value of 4, and the value of permittivity that I am not going to discuss in this lecture, but the value of this epsilon naught is given by the formula 10 to the power minus 12 for vacuum. Right? And if you want to know the unit of this 1 upon 4 pi epsilon naught, so how can you find the unit of this 1 upon 4 pi epsilon naught? You simply shift this r square over there and q1 q2 over there. So the unit will be Newton for the force, for r meter square divided by Coulomb square. So this will be the unit of 1 upon 4 pi epsilon naught. Okay, and if I want to know what will be the value, what we will do with this formula when we are putting these Q1 and Q2 not in space, not in vacuum, then in place of writing 1 upon 4 pi epsilon naught, we will write 1 upon 4 pi epsilon. What is epsilon? Epsilon is simply given by the formula multiplication of epsilon r into epsilon naught. Epsilon naught is the same relativity in space in vacuum, and epsilon r is relative permittivity. Okay, that we will see later. No, it's okay. So we can put in general epsilon here, and epsilon will be epsilon r into epsilon naught. But normally we are considering that our charged particles are in vacuum, are in space, so we will put epsilon equals to epsilon naught, keep by putting epsilon r equals to 1. For space we can say the value of epsilon r is 1, right? So if we want to know the definition of Coulomb, because in starting we said that this unit of Q is Coulomb, C, capital C. So if I want to give the definition of this C, so for giving the definition of C, how can I give? Let's see. How can I give C? I am saying F is 1 upon 4 pi epsilon naught Q1 Q2 upon I square. Right? Okay. Suppose I am saying I am putting F equals to 1 Newton, R equals to 1 meter, then Q will be, what will be the, or we can say that in other words we can say one second, 1 Coulomb. If I put 1 Coulomb here, then, and we will discuss the definition of the charge that when placed at a distance of 1 meter from another charge, then the same magnitude the experience of force which is given by, if I put suppose Q1 this, Q2 this, fine, and I am saying R equals to 1 meter. So what will be the value of F? Okay, so 1 coulomb is a charge when two 1 coulomb charge particles are placed at 1 meter, then they will experience a force which will be equal to 9 into 10 to the power 9 Newton, right? So in this way we can define the 1 coulomb, right? And you see that I said that the charge particles may attract to each other or may repel to each other, and since the direction of the force depend on the nature of the charge, so in this way we will say that force is a vector because it has directions also. It has direction also, right? If they are the positive, then suppose I am saying, suppose this is plus q, this is plus q, the direction of the charge will be like this. Sorry, direction of the force, attraction force, this force will be like this. If one is plus, another is minus, then what will happen? The direction of the force will be like this. So since force has both magnitude plus direction, so what we will say that force is a vector quantity. I hope you understand this. Now if you understand this, and we have seen that okay, all the charged particles have attraction or repulsion with other charged particle. So this means if I am putting 1 plus q over there and minus q over there, so what will happen? This charged particle will attract to this charged particle, right? So this means in this case we can analyze that some lines, some fields will be generated, or we can say it's not, if we say that charge particle is here, so a line will be generated in such a way that it will attract to this negative charge particle, and in this way we can say that every charge particle creates an electric field towards it, and normally this electric field goes from positive to negative, from positive particle to positive charge to negative charge particle. If I am saying the same, I am repeating again, this is plus q, this is minus q. So if we have such type of an arrangement, then this plus q will attract this minus q, and at the same time this minus q will attract this plus q, and an electric field will be created. It will be created, and the direction of this electric field will always be from positive to negative. These start from positive charge particles and will go towards negative charge particle. Is it fine? So electric field lines always moves from positive charge to negative charge. Now the question comes that I said that okay, there may exist a single charge particle also. If I am saying that yes, I am saying that only positive charge particle is existing or only negative charge particle is existing, then what will happen? If I am saying, look friend, this plus q is point charge particle. This is a point charge particle. It's confined only at a point, so this is called point charge particle. Charge particles may be in different shape, that we will discuss later. But if the whole charge is confined at a single point, then this type of charge is called point charge particle. If we see this point charge particle, so in the whole we see, we are not showing its corresponding negative charge. And in starting I said that charge always remains conserved. So if I am only showing the positive point charge, so what does it mean? It means its negative charge will be at somewhere infinity, right? And if its negative charge is corresponding negative charge is at infinity, then how the electric field lines will move? The electric field lines will move like this. It will go to infinity from this charge particle. And this is positive, and we are assuming negative somewhere at infinity. Infinity may be anywhere. So we will show the direction of these electric field lines away from this point charge. Right? The same explanation occurs when we have a point charge particle with value minus q. Minus q, so we will assume that its corresponding positive charge is at infinity, and since it is at infinity, so how will we make its electric field lines? The same, we will make its electric field lines from this, always from radially. You know radially? Radially means if we have the center for any circle, so it will move like this. So this is called the radial. Okay? So it will go radially always. And the direction the direction will be positive to negative. Positive to negative. This is fine. So if we have only a point charge particle, then the electric field lines will move radially from this point charge. If it is positively charged, then it will move towards infinity, and if it is negatively charged, then it will move towards the point charge. And this is called creation of electric field through any charged particle. Right? Now see, we have studied if we have any point charge particle, then point charge particle may have this Coulomb's law. It follows Coulomb's law, and according to Coulomb's law, when two charged particles are placed with each other, they experience a force. Similarly, if we say another kind of force also exists, that force comes in picture when the charged particles are in motion. Okay, you see, the electrons or any charged particle may have number one force when charged particle is static. Means static means it is placed at one place, it is not moving. And this force which we have studied through Coulomb's law is electrostatic force. At the same time, if any charged particle is moving with respect to each other, suppose we have two charged particles and these two charged particles are moving with respect to each other, then what will happen? There will be another force when charged particle moves, and this force is called electromagnetic force. That we will discuss in detail later on, but you can understand the thing at this particular point, that if a charged particle is moving, a magnetic field is developed, and due to the development of this magnetic field, there are another kind of force can be experienced by the charged particle by itself only or by another charged particle, and this is called electromagnetic force. And like when we are talking about the forces on the electrons or protons or any charged particle, so let me allow to write new, or we can say not new, another type of force which is due to the mass of the electron or mass of the proton. And this force due to the mass of charged particle. This is, all of you know well, gravitational force. Gravitational force. So you see, if I say that I have an electron, or you can say two electrons which are placed with each other, and we are considering that the electrons having mass also, having charges also, and they are also moving, then all the three forces will act on it. If we are assuming that the mass of electron is negligible, then and electrons are also moving, at that time we are neglecting the mass of the electron, so there will be no gravitational force. Since electron is moving also, so it has two types of force, electrostatic force and electromagnetic force. And the third case, if I am saying the electron mass is negligible and it is stationary at some place, so we are neglecting the gravitational force as well as electromagnetic force. So this time our charged particle has only electrostatic force. So in these study for this particular chapter, what we are assuming? We are assuming that the mass of the electron is very less, so we are neglecting it. At the same time, we are assuming, or we are considering, that our charged particles are not moving, they are stationary. So we will go for the study with electrostatic force only, right? And for any, in starting we have seen that we have an atom in which we have nucleus, and nucleus has neutron plus protons, and electrons are moving around this here, right? So if we are going to club the knowledge which I have given about the gravitational force and electromagnetic force and electrostatic force, and for the some time you say that you know the mass of proton, mass of neutron, or mass of electron. You know what is the mass of electron? This is 9.1 into 10 to the power minus how much? 31 kg. The mass of proton, mass of neutron is equals to 1.67 into 10 to the power minus 27 kg, right? The charge on proton, charge on electron, magnitude wise same. This is 1.19 Coulomb. Charge on neutron is 0, right? And for some time, I'm considering only the two studies. Number one, electrostatic force. Number two, gravitational force. I'm assuming that they are stationary at some place. Though electron is not stationary, it is revolving. But making our life simple, what I am saying, I am going to show you the relation. First for electrostatic, and for gravitational. So if you have the knowledge of the value of G, and you know the value of 1 upon 4 pi epsilon, which I have given you earlier, 9 into 10 to the power 9, This value is 6.67 into 10 to the power minus 11. So when you substitute all these values, what you will get? You will get the force, gravitational force, electrical force, right? So the gravitational force can be found between any, let's me allow between the P and P, or you can say P and N, because the value of mass for both proton and neutron is same. So when you will solve it, you will get this value 1.8 into 6 into 10 to the power minus 34, of course, Newton. Similarly, electrical force between proton and proton is, when you will solve this, one thing is left which I will tell you after writing this, 230.4 Newton. What I am assuming, the next is that you can find in any book related with your chemistry that the average distance between the two proton is 10 to the power minus 15 meter, and the average distance between one proton and one electron is 10 to the power minus 10 meter. So these two values I am using to find the value according to the formula, right? You know the formula, gravitational forces given by G m1 m2 upon r square, and electrical formula which we have given you early in this lecture, right? So by using this formula you get this. Similarly, if I write the value of Fg between proton and electron, and value of Fe between proton and proton, this is it's okay, it's proton and neutron, and this is between proton and electron. So these values will be 1.0136 10 to the power minus 47, and this value is 2.304 10 to the power minus 8. Okay, this is 10 to the power minus 8. So you see here the value of gravitational force is very low compared to the value of electrical force, and therefore in this way you can neglect the gravitational forces for the study of electrical force when you are going for the study related with electrical charges. Okay, so for studying electrical charges and to make your life simple, to make your calculation simple, you can neglect the gravitational force, because the value of gravitational force is very less compared to the electrical force. Now one question may come in your mind, that if inside the nucleus we have protons which always repel to each other, and the repulsion force is very high compared to this gravitational force, then how they become bonded in nucleus. So I'm not going in detail, I'm giving you only the hint. If you want to study, you can go in your chemistry classes, you can discuss with your chemistry teachers. Then this is because of the nucleus force. Nucleus force is very high, which keep this nucleus always close and bind, and no protons can shoot from this nucleus. Okay, so I'm giving only the hint about what is the nucleus force. It's very high compared to this electrical force inside the nucleus, right? For these small distances, keep in mind, for these small distances. Okay, so I hope in this lecture I'm like stopping myself at this particular point. What we have studied what is charge, what is the structure of molecule, what is the structure of atom, what is the different components in the and what are the different elements, particles in atom, and how they behave, what is the properties of charge, what is the conservation of charge, what are the electric field lines and how they work. So this we all have seen in this lecture. Next class I'll try to give you some conceptual questions related with this whole knowledge of charge which we have studied in this chapter. So this chapter we completed, or we can say that electrical charge we have completed theoretically, but to understand the concepts behind this electrical charge we will see different conceptual questions in terms of examples, in terms of some points in our next class. Okay, thank you very much.